Igneous rocks are rocks that come from molten rock. And you've been looking at a variety of igneous rocks and realised that they actually fall into different categories. They don't all look alike. And there are some distinct differences that helps us to not only categorise them, but to figure out where they came from and where they were formed. Essentially, all igneous rocks are ones that have formed from molten rock, but the big question is, where were they formed when they were solidifying? One of the things that we find with them is that they have interlocking crystals, but not always. We're going to look at that in a minute. We class them in two main categories, intrusive and extrusive. And lastly, we can also find that people will call them by two other names, mafic and felsic, which is actually looking at whether they're light-coloured rocks or dark-coloured rocks. So it doesn't matter where they come from, just whether they're light or dark minerals which make them up. So let's go into these 4 points a little bit more in detail. Okay, so you all know about volcanoes, and you all know that lava comes out of volcanoes. But what you don't always realise is that it doesn't always exit the top of the volcano. So when we look at a volcano like this, we have lava that's coming out of the volcano, and usually we know that it will exit the top of the volcano up here, but often there are little side exits as well. You can actually have lava coming out of weak spots in the crust and pushing out down the sides of the volcano and coming out, like here. And you can even have lava branching off but not making it out. In other words, it gets stuck in little pockets like this. And depending on where the lava stops and where it solidifies, actually determines what sort of rock is formed. Essentially, extrusive and intrusive. So when we think about it, we've got two basic types, extrusive and intrusive. And when you look at them, the essential difference is how quickly did they cool. But it's not so much a one or the other. It's actually more like a big scale, because the quicker it cools, as we've seen in our investigations, the smaller the crystals are, right down to the point where there are no crystals visible whatsoever. So when you have something like obsidian, which is completely black, like this picture here, you can see there are absolutely no crystals formed in it whatsoever. And if we looked at the cutting of this under polarized light, you wouldn't see any crystal formation because they haven't had time to form. This is simply hardened mineral with no crystals aligned at all because it didn't have time to make any. Now we also have to quickly mention one other thing before we go any further. I've mentioned the word a few times, minerals. Minerals are the building blocks of rock, and essentially a mineral is a chemical, a type of chemical. And it can be what we call an element or a compound. An element means it's made up of only one type of atom, and a compound means it's made up of different types of atoms joined together. So here we have a look of it. Different chemicals or minerals can be classed as elements or compounds. Gold is an example of an element. Now when we look at gold, its atomic formula is Au. That is one type of atom. Gold atoms, nothing else joined to it. Whereas compounds like quartz have a formula like this, SiO2, which means they actually have two types of atoms joined together, this Si1, silica, and oxygen atoms joined together. Olivine here is the same. It has magnesium and silica and oxygen joined together. Three different types of atoms. All of these guys are different types of chemicals that when they solidify, they each make their own type of crystal, and that's what we see in the rock. So when we put this to our picture, any of the magma, molten rock, that came out of the volcano like this and cooled extremely quickly, say it fell into the ocean or it came out in an area which it was exposed to an awful lot of cold air and it cooled extremely quickly, has no crystals formed in it or very few, they would be on the extrusive end of this scale because they have little or no crystals that you can see, and the ones that they do have are so small that they actually don't interlock together because they haven't had time to grow into each other. I'm going to show you a picture of that now. Here we have basalt. Now this is one of the rocks that we often see in this area because it's the rock that comes out of volcanoes and is often found on the top of the mountains. Now we can see these lovely little crystals here, but notice they are not growing into each other, and there's these areas of just darkness in between, or in this case over here when we look at it with a different type of light, whiteness. That's not empty space. That's still the minerals that make up the rock in there, hardened into solid form, but they haven't had a chance to organize into crystals. So when we look at them for real over here, you've got this area here where you really can't see any crystals at all. That's this area here. And then we have little crystals dispersed throughout that rock that haven't been able to grow into each other. Now the off side of that is one like this. This is a picture of bronzite. Now this is what we call an intrusive igneous rock, because as you can see it's got lots of different crystals. Each one of these different colors represents a different type of mineral or chemical. But they have actually had time to organize themselves to form into a proper crystal, and as you can see, each one of these crystals actually fits together perfectly like pieces in a puzzle. In other words, they've filled in all the gaps around each other. So as they've formed, they've literally grown into each other. And you can see this in the rock when it's polished by looking at it like here. So as you can see over here, we've got all different types of crystals. We can obviously see some of them are lighter crystals, some of them are darker crystals. That's just because of the type of mineral or chemical that they're made of. But they're all interlocking like this, meaning they had time to slowly form, slowly organize themselves, grow as large as they possibly could, and interlock in the process so they fit together like a puzzle piece. This is the opposite end of the spectrum, with this being an intrusive rock. So when we apply this to where we'd find these, or the other way around, looking at a rock and deciding where it came from, we have to think about what sort of conditions it would need to grow large crystals or not. So essentially any of the lava that's come out of the volcano here, well, magma turning into lava as it comes out, this is extrusive rock because it will cool very quickly and it will have little or no crystals within it. And so we find that along the top of our volcanoes, down the sides of our volcanoes, because it covers and flows down, goes down sometimes even into the water. Some of it will get thrown out of the volcanoes and hit the ocean and solidify very, very quickly. And not only will it have no crystals in it, but because it hits the water and the bubbling ocean, it will actually get bubbles trapped within it. We call that pumice. Any rocks that come out of the volcano and solidify really quickly in the air or in the water, we will find in these areas. So too for these areas here. However, if the rock hasn't made it out of the volcano, it's going to actually slowly cool on its own inside. So any of the rock that we find in the lower parts of the volcano, like here and here, that's been stuck inside the volcano and cooled really slowly, we will find that that will actually have large crystals and therefore be intrusive rock. You'll also find that as you go down further deeper into the earth, you'll have even more intrusive rock. The deeper you go, the slower it takes to cool, the bigger the crystals. So the rocks that have the best crystals and the best size and the best formations tend to be found, of course, deep in the earth. This is why they often cost so much too, because they're very hard to get. So let's just quickly look at these rocks that I've got on the slides here. I've already shown you bronzite, and basalt. Here's another one, granite. And as you can see, this one here has crystals that have grown into each other. So it is again an intrusive rock. Now notice also it's made of very light coloured minerals. Because of this, we would actually call it a felsic rock, which means it has very light coloured minerals like quartz within it. And here we have latite. Now this one, as you can see, here are the crystals, but there's lots of areas here where there are no crystals formed. It again is an extrusive rock and therefore is found in the surfaces around volcanic eruptions. Now one last thing, they didn't always call it intrusive and extrusive rocks. They often called them plutonic and volcanic. Volcanic rocks are essentially extrusive rocks, and plutonic ones are ones that come from deep within the ground. They're the ones we now call intrusive rocks.